All right, I'm going to try and explain as quick as I can what the photoelectric effect is before we go on and look at the quantum weirdness that comes along with it. But the actual effect is not too difficult to understand. So let's say I've got a circuit here like this, and there's nothing in this circuit, so we're having a really big current here, even with a relatively small voltage. So I don't want that to happen because something might get on fire or something like that. So I'm going to break the circuit, and now our current will immediately drop to 0, which is handy. 0 amps. Bold. And that is pretty easy to understand so far. Now, instead of that bit of Y in there, I'm going to put a couple of plates that will become charged plates. Okay, just by the fact that they're in there and they're connected to this battery, this potential difference. This is the positive, this is the negative, and so this plate here is going to be the positively charged plate. This one will be the negatively charged plate. Chemists among you will know these words, but this is what we can call them. They're both electrodes, but the negative one is the anode and the positive one is the cathode. And what the photoelectric effect is having this set up and getting a current through the use of using light, getting a current to flow in this circuit. Okay, so let's look exactly how that happens, and we're going to zoom in on the anode here. So we're going to concentrate on just this electrode. Let's slide across. We zoomed in here on a section of the anode, and like everything in the universe, it is made of atoms. Here is my representation of the atom, that one of the atoms that's making up this anode. There is a nucleus. You can label that the nucleus. You might recognize these pictures from the notes. I've stolen them from there. I didn't really steal them because I made them, didn't I? Electron. And what I have put here is, this is the Greek letter phi. And this thing is called the work function. So phi, do my paint version of it, is the work function. And what the work function is it's the energy that this electron is kind of connected to the nucleus of that atom with. Okay, so really it's this, if this bit here is the surface of, or is the anode, then it's the energy that the electron is bound to the surface of the anode with, phi number of joules. Okay, and that can be that phi can be a different number depending on what that material is, that metal is. Usually these are obviously metal. If it's a metal that doesn't really want to hold on to its electrons, sodium is a good example of that, then phi is a low number. It doesn't take very much energy to break this bond, and then the electron will pop up. So yeah, what's happening is if you put energy into this system, it can be absorbed by the electron. If it is greater than this energy that's holding the electron to the essentially to the anode, to the surface, then it will be ejected from the surface of the metal. Okay, it becomes a sort of free electron sort of sitting out here. And that amount of energy that is required to do that, the amount of energy required to eject the electron, is called the work function. Okay, so how can I put energy into my system? How can I get a current flowing in this circuit, given that I know that these electrons are kind of bound by this amount of energy? Well, I can increase the voltage here, okay, because all that is doing is increasing the energy in the system. So I can increase the energy that's across this gap, and maybe liberate some electrons that way. But that's going to require me getting a bigger battery. Batteries are expensive. I don't want to do that. I want to use something for free. So what you can do is you can use light, and this is the photoelectric effect. You can use light shining onto these electrons to give them that energy. So if we go across to the last picture here, and I'm going to do one thing first before I shine my light on it, which is to encase this in some glass and put it under vacuum. All right, then I can shine my light on it. And what color will I pick? So I picked blue in the notes, but maybe I'll go with green. Yeah, just because I can. All right, so green light coming in onto there. So what is happening if I actually go back here and I'll just grab, maybe I'll just do the green light. I'll do those pictures here actually. Yeah, we'll do that. Vacuum and green light shining onto the surface of the anode. The light is giving energy to this system. So the light is providing the energy that gives these electrons enough energy, as long as it's giving them over this amount, whatever phi is. So let's just say it's make up a number. It can be 10 joules. Okay, this phi is 10 joules. Get rid of that. Make it a 10 joules. So if I give 10 joules of energy to this electron, then it's going to break this bond and it's going to pop out here. It's going to be ejected from the surface of that anode, and it's going to be sitting here. Now we've got a negative electrode sitting right next to a negatively charged plate. What's going to happen? We'll go across here, and it will flow through my ammeter, and it will keep doing that, and we have a current flowing. So my ammeter is going to register something, 0.8 amps in the notes there, because we have energy being given to these electrons that's enough energy to overcome the work function. They get ejected, they then are attracted to the opposite plate, and away we go. We've got a circuit. Because that is being caused by light, these are called photoelectrons, and we've got a photocurrent going through it. And that is that.